Okay, this is section 7.5 on solving radical equations. I want you to notice that there are a couple different radical equations that I've written here. These two are called radical equations. Now, I know that you probably can see that obviously in the first one, and the second one you're like, wait a second, that doesn't look like a radical. Well, keep in mind that's a cube root symbol right there. That 1/3 exponent is a cube root. Um, One of the things that is not a radical equation is this one right here. You can tell because the radical is on a 3. That's a fixed number. It's not on the x. This is a linear equation. You're just going to be subtracting radical 3 to the other side. Not a pretty answer, 10 minus radical 3, but that's the answer to that question. You're not getting rid of a radical in order to answer the question. In these examples, like example 1, in order to solve this, you've got to get rid of a radical. But before you do that, we talk about isolating the radical, which we did a lot of when we isolated absolute value bars. But that's the first thing you need to do is isolate the radical, get the radical all by itself. Now to get rid of the square root, we're going to square both sides. And when we do that, we get 3x minus 2 equals 16. 3x minus 2 equals 16. That's pretty simple to solve from there. You're going to add 2 to the other side, and you're going to divide by your 3 to get your value 6. And you can go back and check that just to be assured that you did it correctly. You have 2 plus the square root of 18 minus 2 is 16, which is 2 plus 4, which is indeed 6. So it does check out to be the correct answer. If you ever want to go back and check, you can always do that. Okay, we'll try one more of those. Isolate the radical, right, by adding 6 to both sides. Square both sides to get rid of the radical. And then from there, it's a pretty simple problem, right? You're going to subtract 1. You're going to divide by 5. There you go. Well, what about when you get to these particular types of questions? Well, first of all, the radical, which is inside this whole parentheses situation here, is not isolated. So we do have to isolate the radical first by dividing by 2. Please do not try to distribute that 2. Okay? No distributing. Do not distribute the 2. Okay? That is going to get you in a world of hurt. So we have x minus 2 to the 2/3 equals 25. Okay, now here's what we need to do. We need to get that exponent to become a 1. So in order to do that, we need to raise both sides to the 3/2 exponent. You'll notice that I chose a reciprocal exponent to 2/3. So raise both sides to the 3/2 exponent. Obviously, 2/3 times 3/2, those are going to cancel out, leaving me x minus 2. On the other side here, I have 25 to the 1/2 to the 3rd. Now, I want you to keep in mind, this is a different situation. This is a solving situation. And just like when we have x squared equals 25, and the answers are plus and minus 5, completely separate issue or problem. The same thing's going on here. But I have x minus 2 equals plus and minus 5 raised to the 3rd power, which equals plus and minus 125. So x minus 2 equals 125, and x minus 2 equals negative 125. Please do not solve one of them, get the answer, right, 127, and then think that the other answer is negative 127. That is not true. When you add 2 to this side, you get negative 123. So my two answers are 127 and negative 123. So, get it down here, then set up your two little equations and solve both of them to get the correct answers. Let's try another one of those. See what happens on this one. I know it's kind of hard to see. That's a 3/2 exponent. The first thing I do is divide by 2 because I've got to isolate the radical. So we have x plus 3 to the 3/2 equals 27. Okay, to get rid of that 3/2 exponent, we're going to raise both sides to the reciprocal exponent 2/3. These will cancel out, leaving me x plus 3 equals, so we have the cube root of 27 squared. Now, we said that the odd powering functions have only one answer for everything, not two answers, like up here. Or when we were doing the even root of a positive number, that's how we got the two solutions. Here we have an odd root. So there's only one cube root of 27, and it's 3. So we have x plus 3 equals 3 squared, or 9. Therefore, x would be 6. So this is not a situation where we ended up with two answers. We only ended up with one answer because we were taking an odd root. The last situation was an even root. Okay, in example 3, it says a solar energy. A company manufactures solar cells that produce 0.02 watts of power per square centimeter of surface area. A circular solar cell, well, that's where we get the area of the cell. It's a circle, so it's pi r squared. Needs to produce at least 10 watts. What is the minimum radius? So if it's 0.02 watts of power per square centimeter, we need to multiply by the square centimeters and get at least 10 watts of power. So this will help us find the radius. Well, so we're going to divide by 0.02, and you know what we can also do? We can divide by pi at the same time because those are just numbers, right? So we're going to divide by 0.02 and pi. It's a quantity, so we can use parentheses when we use our calculator. Okay, so now we can take the 10 and divide by parentheses 0.02 pi. I showed you to use parentheses, and you can use those here as well. When I hit the equals button, I get 159.15. 159.15. So it says r squared is greater than 159.05. The last thing we need to do then is take a square root, or we can say raise it to the 1/2 power. Since we're doing fractional exponents, I'll just do that. And I can take my answer on my calculator and leave it in there and use it, right? And just hit the caret symbol and type 0.5. And then I end up with 12.62. 12.62. So r is greater than or equal to 12.62. As long as I have a radius bigger than 12.62 centimeters, then I know that I will have enough power. And that's example 3. Moving on to example 4. Example 4 is another solving situation. First thing I need to do is isolate the radical. So I have square root x minus 3 equals x minus 5. Now, when you square both sides here, hopefully you see on the left side you just get x minus 3, but on the right side, gonna have to FOIL that, right? X minus 5 times x minus 5. And, pick your favorite method on how you want to FOIL that. We got x squared minus 10x plus 25. Now, interesting. How are we going to solve this one? Well, quadratics, we need to push everything to one side, setting it equal to 0. So that leaves me with x squared. If I have negative 10x and I'm subtracting an x, that'll make me negative 11x. And if I have 25 and I'm adding 3, that'll make 28. Now, a couple different ways we can try to handle this. We can try to factor it, or we can try to use the quadratic formula. Let's see if it factors. Can we think of two factors of 28 that add up to 11? Well, I can do that. I can come up with 7 and 4, right? And they both have to be negative so that they add up to negative 11x. So, setting each one of my factors equal to 0, I know that a lot of you probably won't need to do this anymore. You come out with solutions of 7 and 4. Now, before I think that that's my final answer, notice what it said up here. Check for extraneous solutions. It is possible to do the math and actually create a solution which is not true. So go back to the beginning. I know this is your least favorite thing on the planet. And check. Square root 7 minus 3 plus 5. Is that equal to 7? Let's see here. So that's square root 4 plus 5 equals 7. Okay, that checks out. That's 2 plus 5. Square root 4 minus 3 plus 5. Is that equal to 4? 4 minus 3 is 1. It's 1 plus 5. That doesn't equal 4. So this is not a true solution. So we have to cross that one off. This one is extraneous. And this one is our only actual solution. Now, they were both possible. So if you were thinking in terms of possible solutions, 7 and 4 are both possible. But then we found out that 4 was extraneous and 7 was the only actual solution. So let's try a different question. Okay? We want to isolate the radical. We want to square both sides. I'm going to FOIL this rather quickly if you want to use a box or whatever. X squared minus 6x plus 9. If you want to write that out and FOIL it, that's a good idea. Then we can move everything over to this side. X squared minus 11x, 9, positive 10. See if we can factor it. X minus 10, x minus 1. And my two, so we can write down possible solutions, extraneous solutions, actual solutions. As far as possible solutions, it looks like 10 and 1 are both possible. But we need to check, right? Go back to the beginning. The square root of 5 times 10 minus 1 plus 3. Is that equal to 10? Well, that's 50. That's the square root of 49 plus 3 equals 10. All right, so that one works out. So 10 is an actual solution. Let's try again with 1. All right, so we got square root 5 times 1 minus 1 plus 3. Is that equal to 1? 5 minus 1, 4. Square root 4 plus 3. That is not equal to 1. So 1 would be considered an extraneous solution. This is the format that you'll probably see on quizzes and tests where I ask you for the possible solutions, any extraneous, and any actual. If you should think that something is not a solution, if you don't think that there are any extraneous or any actual solutions, then you would write the word none. We'll talk about that in class as well. But you would write the word none if by any chance you would think that there are none of a particular type. But for this question, these were the solutions. Let's look at example 5. Example 5 presents a different challenge. Okay, you've got two different radicals, but they're not the same. They're not the same radical. So I'm going to throw this radical on the other side. So I got 2x plus 1 to the 1/2. And on the other side, then, because that was a negative here, it's going to be a positive on the other side. 3x plus 4 quantity to the 1/4. So I've got radicals on both sides. Now I want you to think about this. If I raise both sides to the second power, that's going to eliminate this exponent, but not this one. So instead of raising it to the second, I'm going to use the least common denominator between 2 and 4, or least common multiple, I should say, of 2 and 4, and that is 4. Now, on this side, these are going to cancel out and leave me with 3x plus 4. And on this side, it's going to be 3x or 2x plus 1, and then 4 times 1/2 is squared. Now we've gotten rid of our radicals. We can FOIL this, right? 2x plus 1 times 2x plus 1. Four x squared, 2x, 1. Gives me 4x squared plus 4x plus 1 equals 3x plus 4. Bring everything over. 4x squared plus 1x minus 3 equals 0. Okay? And let's see about factoring this. If you were with me before, you know I use a different technique for factoring this kind of problem where there's a 4 in front. And if you need some practice with this, I'll be happy to help you in class. But I take my 4 times my 3. It's going to look, if for those of you who've not seen this, it's going to look kind of like a magic trick. I change this by taking the 4 down with the 3, and that makes x squared plus x minus 12. It kind of looks like I just took away the 4 and got rid of it. Don't worry, it'll come back here in a second. I factor this normally. I've got 1x and 1x. One's a plus and one's a minus. I need factors of 4 whose difference is 1. That would be 4 and a 3. Here's where the 4 comes back. I put the 4 back in front of my x's. Very last thing I do is I look for a greatest common factor inside of each set of parentheses, and if I see a greatest common factor, I pull it out and I throw it away. So x plus 1. 4x minus 3 does not have a greatest common factor, so I can't do anything with it. And now I have it factored, folks, and there's no guessing and checking on what I should have been. And so that's what I do in all my factoring when I have something that doesn't have a coefficient of 1 out in front. So in other words, now I can set up my factors. X plus 1 equals 0, and 4x minus 3 equals 0, and I can solve them. So x equals negative 1, and 4x equals 3, x equals 3/4 is my second example. We'll come back to this example in a little bit. Want to check my answers out, go back to the original problem. I've got 2 times negative 1 plus 1 raised to the 1/2 minus 3 times negative 1 plus 4 to the 1/4. Okay, let's see here. That's negative 2 plus 1. That's negative 1 to the 1/2. Uh-oh. Got a problem. Okay. That doesn't exist. Okay, there's no real number. No real number for that. So, in terms of my possible solutions, yes, I had negative 1 and 3/4. But in terms of extraneous solutions, here, I'll just do extraneous. We just found out that negative 1 is an extraneous solution. So now let's try 2 times 3/4 plus 1 to the 1/2 minus 3 times 3/4 plus 4 to the 1/4. Gonna have to grab that calculator because this looks ugly. 2 times 3/4 plus 1. Take the square root of that. That's 1.5881. So let's see what 3 times 3/4 plus 4, and raise that to the 1/4 power. I also get the same result, so when you subtract these things, they would cancel out. So in terms of actual solutions, 3/4 is the only actual solution. Okay, that last example that I had there up there on the screen is actually easier than this than the past one because both of the roots are square roots. So yes, I am going to push that one to the other side. But when you square both sides, nice things happen. You're left with a linear binomial on both sides. That's very easy to solve, right? You're going to bring the 2x to this side. You're going to bring the 2 to that side, giving me an x value of 5. And there you go. That was a very easy one to solve, especially compared to that last one.